today we are going to do systems of linear inequalities. On Friday we did just one linear inequality on a graph. Today we're going to do two linear inequalities on a graph. That is why I had you get two different kind of types of writing so that you can see commonalities, where the common areas are. So we're basically going to put what we did on Friday, except for we're going to do two of them together on the same graph. Okay? It can get kind of confusing if you don't have maybe a couple of colored pencils or something. I need you to fix the equation on example 1. The first equation should say y is greater than 2x minus 5. So that was an error on the notes. So cross out that 2 and make it a y. All right? Y is greater than 2x minus 5. So we need to graph that line on our graph. We have y is greater than 2x minus 5. Is that in slope-intercept form? Yes. What's my y-intercept? Negative 5. So we're going to put a point at negative 5 on our graph. What's the slope?
2 over 1.
2 over 1. That means we go up 2, right 1. We're going to go up 2, right 1. Put points all the way on your graph here. And we can also go down to left 1. So put points all the way down your graph, please. Now, before you connect the dots, though, I want you to think about something. Is this?
It would be a dotted line.
Oops. Oh, I don't want to do that. Okay, it's going to be a dotted line. Because it's greater than. It's not greater than or equal to, it's just greater than. So we're going to do a dashed line.
Why does it have to be dash and dot?
Well, that was Friday's lesson. Okay. If it's just greater than or just less than, it's a dotted line. It's just like the open closed circles when we did inequalities. All right. Now we're going to shade which side it is. It's y is greater than 2x minus 5. Is it above or below?
Above.
It is above. Greater than. So we're going to shade everything above the graph. Now, do not shade this in very dark because you're going to have to see the graph still to graph the other line. So you just kind of want to do some squigglies in there just to kind of shade it in a little bit.
Wait, hold on. Can I ask a question?
Yes, you may.
No, I'm probably going to get in trouble for asking this, but what? Oh, never mind. I'm not going to
Ask me, Dexter.
No, I'm going to get a whole bunch of crap for asking.
You sure are. Just ask
Well, you already brought it up.
This is probably why I'm failing the class.
All right, now.
Because you don't pay attention.
So now we're going to do the other line, or the other inequality, and we're going to see where they overlap. All right? The other inequality is 3x plus 4y is less than 12. It's not in slope-intercept form. We got to get it that way. So we got to get the y by itself. Subtract 3x from both sides. So you get 4y is less than negative 3x plus 12. Yep, and then we divide by 4 on both sides. Divide everything by 4, every term by 4 here. So we get y is less than negative 3/4 x. 12 divided by 4 is 3. So y is less than negative 3/4 x plus 3. Now keep in mind on inequalities, had we divided by a negative 4, we would have had to flip our inequality symbol. So don't forget about that rule. None of the examples have that in here today, but your homework probably does have some where you have to flip the sign. So y is less than negative 3/4 x plus 3. So where are we going to start at on this line? 3. So we're going to put a point at 3. Now the slope I want to talk about a second because a lot of you guys mess up when you do a negative fraction slope for some reason. You have to put the negative with either your rise or your run. So let's say I put it with the rise. Negative 3, positive 4. That means I go down and right. Or I can go positive 3, negative 4, which means up and left. So try not to make a mistake on these negative slopes like that. So down 3, right 4. I'm going to go in both directions. Down 3, right 4. Down 3, right 4. And go the other direction as well. Okay, is this a solid or dashed, did we decide? It's a dashed line. draw a dotted line all the way through here.
So what is the? Wait, why? What if it's? What does it have to be solid?
Or equal to, like a little line.
What if it's
like
less
this.
than or greater than, then it's always dashed.
Yeah.
Oh, that's easy.
Now we need to decide if we shade above or below. Let's look at, now, if you're going to use the method like I showed you, where you just look at the inequality sign, you have to use the slope-intercept form to look at that inequality. You can't go back up to the original. Y is less than negative 3/4 x plus 3. We're going to shade above or below? Below. So we're going to shade everything below. This is where you're using your different type of color or pen versus pencil or something to kind of show the difference between the two.
So what do we do with the space that is left over?
You'll see. So just kind of shake that in.
Nothing. We do nothing.
I'm gonna need a second color design.
So this common region is where you have both colors or both your pen and your pencil overlap. This overlapping region is the solution to this system of linear inequalities, because any coordinate point you take out of this region right here, past it. In this region, anywhere in this region right here, any coordinate point in this region right here will be the solution to this system. It would make all the coordinate points in that common area will make both inequalities true.
Wait,
So
so
that's
get
your-
another color out?
This is your answer. I was just kind of highlighting the answer. So your answer is this. All of these coordinate points are your solutions to the system. This is a system of linear inequalities where all of these that I've highlighted in black here, all of these coordinate points will make both inequalities true, which means it's a solution. So all of these coordinate points are solutions. The ones where there's nothing, the one where there's no color, that means those coordinate points will not make either inequality true. The ones in blue, the shaded area in blue, will only make the first inequality true. The ones in red will only make the red inequality true, the second one true.
So we're just doing this so we can find other points to solve them?
Yes, but the actual answer, the actual solution, is the region where they are combined. These are not solutions. None of these coordinate points on the right side here are solutions.
Is that all we have to do to solve the problem?
Yeah, that's it. That's the answer. Your graph will be the answer. Okay.
Is it a lot easier than
That
that?
is not whack, Miss D. That's not whack.
Hey, can you open a window?
No. Okay. All right, example 2, we're going to have to go backwards. We're going to be given a graph, and we have to write the inequalities that this graph represents. So we have to write the inequality that this graph represents. There's two inequalities. There's two lines up there. We have to find the equations of the lines first, okay? So step 1 is just find the equation of the line. Let's look at this solid line right here first. We have to figure out what the equation of that line is. What do we need in order to write the equation of a line? We need a slope. What else do we need? The y-intercept. Do we have both of those things?
Yes.
All right. What's the slope going to be? 1/2, because we have to rise 1, run 2. So the slope is 1/2. The y-intercept, it crosses at right here, -1. So then our equation is y equals 1/2 x minus 1. That's the line, that's the equation of that red line. However, this is an inequality because there's shading going on. So rather than keeping it an equation, we need to turn it into an inequality. To do that, we need to figure out, instead of the equal sign, what do we actually need to put? So when you look at it, is it shaded above the red line or below the red line? Above, so it's greater than. Now, is it or equal to? Yeah, it is because it's a solid line. So it's greater than or equal to 1/2 x minus 1. So that's one of the inequalities. That takes care of the line that's got a slope to it. Not yet. We have one more line to deal with.
Oh, there.
This dashed line right here. Now this is a horizontal line. What do we know about equations of horizontal lines? Well, the slope is 0, but how do we write the equation?
Y equals m
Y equals
1
Yeah, y equals where it crosses the y-intercept. That's the equational line. Y equals 2. Guys, I've told you guys this several times. If they're horizontal lines, it's y equals, that looks like an X. If it's a horizontal line, it's y equals wherever it goes through. It's going to be y equals some number, wherever it goes through the axis. If it's a vertical line, it's going to be x equals some number, wherever it crosses the x-axis. So those are the equations of vertical and horizontal lines. You can't forget how to do those. But it's not x equals 2 because there's shading going on. The shading, is it above or below that line? It's below, so we want less than. Do we want or equal to?
Good one.
Weird. Oh, I thought.
So that's the answer to example 2. Just 2 inequalities. You just write the 2 inequalities and you're done. Okay? Let's look at the last example, please. All right, you want to build, or you want 2 fence. That word A should be 2. You want 2 fence, a rectangular garden plot. You want the length of the garden to be at least 50 feet. You want the perimeter to be no more than 140 feet. So those are our 2 inequalities we're going to write because this is a system of inequalities. We have that it needs to be, the length has to be at least 50, perimeter no more than 140. There's our 2 inequalities we're going to write. Solve by graphing to show all the possible dimensions of the garden. Let's start with our variables. What are our 2 variables? If you look at the graph, it'll tell you. Length and width are 2 things we need variables for. They have the width down here on the x-axis. So we're going to go ahead and call the x to be width. And we'll have y be length. Okay? X is width, y is length. So we have one inequality that says that the length has to be at least 50 feet. So length, which is y, has to be at least 50 feet. So what kind of inequality can we write for that? At least 50 feet. So what sign am I going to put in there? Greater than or equal to. There's one of your inequalities. Y is greater than or equal to 50. The other one has to do with perimeter. Perimeter can be no more than 140 feet, which means we're going to use, yes, less than or equal to. But we first have to figure out what perimeter is. How do we find perimeter? Add up all the sides, right? There's 2 lengths and 2 widths. So the formula is 2x plus 2y. That's perimeter. It has to be less than or equal to 140. So those are our 2 inequalities. All right, let's go ahead and turn this second inequality into slope-intercept form so that we can see what our y-intercept is going to be so we can tell how we're going to scale our graph. So we want to get y by itself. So we're going to subtract 2x from both sides. And you get 2y is less than or equal to negative 2x plus 140. Yes, thank you. Divide everything by 2. And you end up with y is less than or equal to negative 2 over 2. Negative 1x. 140 divided by 2 is plus 70. All right, so we have 2 inequalities. We have this one. I'm going to put in blue. I'm going to graph with blue. And then we have this one right here that I'm going to graph in red. We'll start with the blue one. Y is greater than or equal to 50. Actually, before we can start graphing them, we have to scale our graphs here. If I need to reach 50 and 70 on my y-axis, how am I going to scale this? Tens is probably pretty good, so we'll do it by tens. So we'll scale both the x and the y-axis by 10. Okay? Alright, so on the blue line, we need to graph the equation y equals 50. What does the equation y equal 50 look like? Horizontal line that goes through 50 on the y-axis. Now, is this going to be a solid or a dotted line? Solid, it's or equal to, okay? Are we going to shade above or below? Above, because y is greater than or equal to 50. So we're going to shade all this above here using one color. Remember, don't shade in too much because you still have to see your graph to be able to use it. Alright, our equation is y is less than or equal to negative 1x plus 70. Where do we start with that one? We start at 70. Now let's answer this question here. Our slope is negative 1 over 1. Alright? That means we go down one, right one, correct? But how is my graph scaled though?
Up one, left one, or up one, right
No,
one.
look at the scale. So if I go down one, how many am I going down?
10.
If I go right, how many am I going? 10. Okay, so if I go down 10 and right 10, is that still the same thing?
Yeah.
Is that the same?
Yeah.
So I can still go down one, right one, even though we're actually going down 10, right 10, still works out. So we're going to go down one, right one, all the way down your graph. Solid or dotted? Solid. And then it's y is less than or equal to negative 1x plus 70. So to the left or down below here. So where's that common region?
It's very long.
It's not very big, is it? It's just this little, I'm going to use kind of a different color to highlight it, but it's this region right in here. That's our common region. So, and we can have points on the lines or inside the triangle. So these are all possible dimensions of your garden. That's what all this means. Like, that's why we did all this, was to find out where is that region. What are my possible coordinates, or my possible values for length and width? If you use this, you can pick any coordinate point in this region. Example, you could use 10, 60. You could have width of 10, length of 60. You could do
1055.
You could do 10, 55. Yeah, anything in this region will allow you to keep within those parameters, or those inequalities. So that's how you do those. So you just have to be really kind of neat on your graphs, otherwise they can get pretty messy. All right. Thank you for listening.